This is a problem that contains a pattern that I have encountered pretty frequently lately, especially in the Leetcode contests. This was from a couple of weeks ago. There was another one a couple of weeks before this. And as I've been going through some sliding window problems on Leetcode itself, this is a pattern that I've seen that can be applied to at least 10 problems that I've seen. So it's definitely a good one to know. And the reason for doing this video is I have not been satisfied with the video explanations of problems that fall under this pattern. And the main reason for that is the fact that most people try to solve these problems using prefix sums, which obviously is more than okay for a Leetcode contest because it's O of n time complexity, which is the same time complexity as the solution I'm about to show you. However, the space complexity is not optimal as it's O of n space for a prefix sum. And in a Leetcode contest, that's completely fine. But in an interview, I don't think that would cut it, especially because this is only a medium tagged problem. So the solution to this is pretty simple, and it can pretty much always be universally applied to problems where you see an output here where you need to count the subarrays. And on the surface, this problem is pretty simple to understand. Basically, you just need to return the number of subarrays where the max element appears k times. The max element here, and in this example being 3. I have changed the final value to 0 to just illustrate my point a lot better from a 3 here. So this output will not be the same. But the reason why people resort to prefix sums here is because a traditional sliding window method of widening the window and then compressing the window doesn't seem to work at first here. And let me go through why that is before I offer the solution. So in a traditional sliding window, we have the result and we have the count. We increment the right pointer. Once we land on the max element, which is obviously 3, we're going to increment the count by 1. Then we're going to keep going until we encounter the max element again. Then we're going to increment the count by 1 again. Once the count equals k, what we do is we increment the result variable, and then we execute a while loop that moves the left pointer all the way from the left up until the window is still valid. So it cuts off everything that's not kind of contributing to whether or not the window is valid or not. And what we would do at that point is we would increment the result by 1 every time we move the left pointer over. So in this case, the left pointer would just move over once because this is still a valid window. And where people run into trouble is now so the left pointer is now here, the right pointer is now here. Once we move the right pointer here, k still equals the count. So the count doesn't change. K still equals the count. And so what we do is we increment the result by 1. However, the subarray that we're looking at is this subarray. And there's still one more subarray before that. And it's right here, 1 all the way to 0. This is still a valid subarray as well. And so the traditional sliding window doesn't take into account that. And it can be really frustrating trying to figure out, oh, then do I move the left pointer back, that kind of thing. But there's a way easier, and then if you do that, then obviously it becomes, the time complexity obviously changes. So one way to solve this where we're just using constant space, but still linear time complexity, is what I call the bucket method. And we're going to start the exact same way, and it's rather similar. Besides, we're going to have another variable called the bucket, and we're going to set that variable to 0. So in this example, let me just get rid of this. In this example, we are going to start the exact same way. We're going to move the right pointer again, move the right pointer again, till the count, here the count's 2, equals k. Once the count equals k, what we're going to do is instead of just adding the result, we're also going to add the bucket. So we're going to add, instead of just adding 1 to the result every time the count equals k, we're also going to add the bucket to the result. And this should make sense after I go through this a little bit more. But for this first example, we're going to add 1, and then we're going to add the bucket. The bucket is 0, so 1 plus 0 is still 1. And then while the subarray is still valid, we're going to obviously move the left pointer. So we're going to move the left pointer here, which in turn snips this off. We're still going to increment the result by 1, but instead we're also going to add 1 to the bucket. And this should make a lot of sense given the last example, because then once we continue the for loop and move the right pointer to the end, instead of just adding 1 here, which we're still going to add 1, we're also going to add the bucket, being 1 as well, so we get a final result of 4. And what's great about this method is it can really be applied to pretty much any problem where you're being asked to count the number of valid subarrays. Here is the code. Pretty similar to a typical sliding window in terms of the initialization. First, we're going to initialize the res to 0. We're going to then initialize the count to 0. Then we're going to initialize the left pointer to 0. And we are going to store the max in this max nums variable. So the max of the array is in this max nums variable. The one thing that we're going to change that's different from a typical sliding window is we're going to introduce this bucket variable. We're going to initialize that to 0. Then what we're going to do is we're going to loop through the array, and we're going to check every time the right pointer lands on the max number, we need to increment the count by 1. So and the reason why we need to do this is obviously we have the sliding window here, we have the left pointer here, we have the right pointer here. Every time we move forward, we need to keep a count of how many max numbers we have. And so here in this example, we'd have 1 here, and then we'd have 2, and then we'd have 3. And that leads us to the next check that we have to do is if the count is greater than or equal to k, and the greater than is important, which I almost made that mistake, is you need the greater than because this is a valid window, but then this is also a valid window. So the maximum element needs to appear at least k times, so it's not exactly k times. So the count can be greater than k, and this should still execute. So every time that happens, what we need to do is we need to do 2 things. We need to increment the res by 1, and then we need to increment the res by the bucket. Initially, the bucket is obviously set to 0, so in this example, we'd only be adding 1 to the res initially. But then this brings to the next part of the code, which is the while loop, which is basically what we were doing was we were widening the window. Now what we need to do is we need to compress the window, which means we moved the right pointer out here. We now need to move the left pointer in. And what we're going to do in this example is we're going to move the left pointer as long as the window is still valid, we will continue to move the left pointer. We will never move the left pointer past the point where the window is no longer valid. So in order to check for that, what we need to say, we need to have basically two conditions, and either one of these conditions needs to be true for the while loop to continue. So what we're going to check for is, we're going to check for while the count is greater than k. And the reason we're starting with this is we already know that the count is greater than or equal to k. So whenever the count is greater than k, we know we need to keep moving the left pointer, because that means we have more than k elements, k max elements in our count. So we need to keep moving it, because this is a valid subarray, but this is also a valid subarray, and this is also a valid subarray. So we need to keep moving it past that point. And then what we're also going to say is we're going to say or. So this loop is going to continue here, and or it's going to continue if the num, so if where the value that the left pointer is at is not equal to the max number. And this is the case because in this example here, the count is currently k, so the count is equal to k, so this first condition won't execute. So it'll move to this, and we do want to move it over when the count is the count here is 2, k equals 2. So we still want to snip off this 1 here. And what will happen here is we will increment the res by 1 again, and then we will increment the bucket by 1 as well. Lastly, the last check that we have to account for is if the nums that is the left pointer is at, if the value is equal to max num, we need to then decrement the count by 1, and then we need to obviously keep the left pointer going forward, and then at the end all we need to do is return the result, and this should run. There you go. And this